Welcome back to the workshop. We want to take a look at another example for section 3.1, random variables. And one thing that I didn't mention in the previous video is that we're working with discrete random variables, which means that our inputs for it can be listed or are finite, which of course would also give that the outputs can be listed or are finite. So let's take a look at our next example. All right, so a couple is planning to have 3 children. Yay, 3 kids. So we want to assume that it is equally likely that they will have a boy or a girl for any of the individual children. So if we let B represent having a boy and G represent having a girl, the possible outcomes and their probability is given here. So they could have a boy, boy, boy. They could have boy, boy, girl. They could have boy, girl, boy. And of course, this is giving a particular order. And we should recognize how to find each of these probabilities from our discussion in chapter 2 about probabilities. So we find anyway that the probability, or that we have all of these different scenarios. So we would have, because order matters here, but we don't necessarily want to consider order, and thinking about how many girls they might have, we still have to account for all situations. So let's let X be the number of girls the couple has. Okay. So how many girls could they have? Well, of course, if they're only having 3 children, then it's 0, 1, 2, or 0, 1, 2, or 3. There's 4 options: 0, 1, 2, 3 girls. So what values does the random variable take on for each of these possible outcomes? Well, 0 girls here, 1 girl here, 1 girl here, 2 girls here, 1 girl here, 2 girls, 2 girls, and 3 girls. So we pick out an element from the sample space. That element is the gender of the children that they had, boy, girl, boy, and we see how many girls that is. That's 1 girl. Okay, excellent. So that's the context, right? We have a very understandable why is our random variable taking on a particular value for the outcome in the sample space. Makes sense. This is pretty straightforward. So what we want to, let's see here, what we want to observe, of course, is that this is acceptable. This is going to give us a probability measure, equally likely outcomes. There are 8 of them. Pretty straightforward to see that. So I think we're good. So we should be able to say with confidence, this is a discrete random variable. Excellent. Again, discrete because the possible inputs are finite or countable or enumerable, that is, they can be listed. All right. So what is the domain of the discrete random variable X in this case? Well, the domain in this case is the order of genders of their children. So the domain is the 8 possible orders, gender orders, of the 3 children. Okay, so that's the idea, right? Again, context, which is nice to have. So they could have boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and then finally girl, girl, girl. Right, so that's our sample space. That is the domain of our random variable X. All right, what are the possible values of the discrete random variable? Well, those are just the outputs, right? How many girls can they have? So the possible values are, right, lowercase x, our random variable could take on the values 0, 1, 2, or or 3. All right, so what outcomes constitute this particular event? Remember, when we say random variable equals 2, we're talking about the event of all outcomes where the random variable takes on the value 2. So that would be what outcomes? Well, that would be the outcome, the outcomes of having 2 girls. So x equals 2 is the event that the couple has 2 girls. Excellent. That's easy. That's pretty straightforward. And what ones are those? What are the outcomes there? That would be boy, girl, 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 boy, girl, and girl, girl, boy. Excellent. And let's determine that probability. What is the probability that x is equal to 2? Well, there's a couple different ways that you could calculate this. All of the individual outcomes are, of course, disjoint or mutually exclusive. Rather, they're all distinct from one another. So if I wanted to find this, I could simply add up the probabilities of the individual outcomes in the event. Okay, so all outcomes equally likely. Since they're equally likely, I can actually use the classical probability model. It doesn't matter. We have this luxury when we talk about all outcomes are equally likely. So use classical probability. That is, we consider how many ways there are to have this event occur, which is 3, and we divide it by the total number of outcomes in the sample space, which is 8, and we get 0.375. Now, if you wanted to add up the probabilities of the individual events or the individual outcomes, right, there's 3 outcomes, all equally likely, 1/8, 1/8, 1/8. If you added those 3 probabilities together, of course, you'd still get the 3/8. You get the same thing. All right, so that is discrete random variables, events, a little bit of notation, that sort of thing. So we should be all set with discrete random variables, and we can move on to talk about a little bit more about them, using them. So I'll see you guys back in the workshop for section 3.2 very soon.